relating the terms exothermic and endothermic to the temperature changes observed during chemical reactions. We'll also try to demonstrate understanding that exothermic and endothermic changes relate to the transformation of chemical energy to heat energy and vice versa. So at the end of this lesson, you should be able to understand how the term exothermic and endothermic relates to chemical reaction, and relating the two terms to energy transformation that takes place when chemical reaction occurs. Okay, so basically, to just do a quick recall, remember that energy can be transformed from one form to what? To another. So in this case too, we're focusing on how chemical energy is being transformed into heat energy, and how heat energy is being transformed into chemical energy. So we'll be dealing with the following key words. We'll be looking at the term energy, because the term energy means the ability to do work, which is measured in joules. Bond has to do with the chemical connection between two elements forming a compound. Example, HCl. There's a bond between hydrogen and chlorine. Of course, you know this is a covalent bond. If you have forgotten, try to recall formation of covalent bond. So this is what we call a bond, and a bond is usually represented by an hyphen. So for example, in water, okay, we have two bonds, one between oxygen and hydrogen, and the other bond between oxygen and hydrogen on the other hand. So this is a bond and this is another bond. So bond is just the chemical link between two elements in a compound. So exo and endothermic. The word exo here will just relate to external. The word thermic is taken from the word therma, which simply means heat. Okay, therma, which means what? Heat. So when you say exothermal, that simply means heat on the outside. Okay, heat on the outside. That is exothermal. So when you say endothermal, you're simply saying heat energy on the inside, or taking in heat energy. Exothermal means releasing heat energy outside, pushing heat energy outside. That is exo. So exo means heat energy is being pushed towards outward, while endothermic simply means heat energy is being absorbed inward. Okay, so the last term here talks about enthalpy, which simply means heat changes. And that's what we want to try to focus on. When chemical reaction takes place, it is usually accompanied by changes in heat energy. The change could be towards an increase in temperature or a decrease in temperature. So either ways, we have change in heat energy. So that change in heat energy is referred to as what? Enthalpy. Okay, so you have your quiz, your pop quiz quickly. 4 questions which you should try to do in 3 minutes. So this is your first one question, question 2, this is question 3, and this is question 4. So you can pause the video and do the quiz. Then when you are done with the quiz, you have to do self-assessment. Okay, so pause the video, do the quiz, then you play later on and you see the answer to the quiz and your mark. Okay, just have enough integrity to pause the video and actually do the quiz before seeing the answer. Okay, so you need to own your learning at this point, very important. Okay, the answers 1, 2, 3 and 4. So let me quickly do an explanation of the answers to this quiz so that you can learn very well. Okay, so the first question here says aluminium react with iron oxide as shown. So you can see the reaction between aluminium and iron oxide, forming iron and what, and aluminium oxide. It says which statement about this reaction is correct. So basically aluminium oxide is oxidized, because you can see that aluminium is changed to what, is changed from aluminium to aluminium oxide. So basically it's obvious here that oxygen is being what, added. The only difference between aluminium Al and aluminium oxide is what, is this oxygen that is added. So aluminium is oxidized. That's straightforward. This question 2 say which oxide is oxidized in this reaction. So first you ask yourself, what are the oxides I have in this reaction? Okay, so let's try to name the oxide we have. This is iron oxide, this is carbon monoxide, this is carbon dioxide, this is zinc oxide, this is carbon dioxide, this is iron oxide, this is aluminum oxide, carbon monoxide, nitrogen monoxide, carbon dioxide. So let's take it one after the other. You will understand. Just follow me. So if you look at this, iron oxide is changed to iron what? To iron. So that's removal of oxygen. That's reduction. Here, carbon monoxide is converted to carbon dioxide. So here you have one oxygen, here you have two oxygen. I have an increase in oxygen, and that's the only change where we have an increase in what? In oxygen. Okay, for a particular oxide. So the oxide that is increased here is carbon what? Carbon monoxide, and that's why the answer here is what? Is B. So zinc oxide is reduced to zinc, removal of oxygen. Iron 3 oxide is reduced to iron, removal of oxygen. Carbon monoxide here is changed to what? Carbon dioxide. You can see that is an addition of oxygen from 1 to what? To 2. So the answer is carbon monoxide. Okay, number 3. Say which substance is oxidized in the reaction? Which substance is oxidized in the reaction? Following the same principle of removal of oxygen or addition of what? Oxygen. Reduction is the removal of oxygen, while oxidation is the addition of oxygen. So if you look at this, chromium is changed to chromium oxide, is changed to chromium. You can see oxygen has been removed here. Okay, so that is removal of oxygen. That is basically what? That is reduction. So but in this case, aluminium is changed to aluminium oxide. Okay, so that means oxygen is what? Oxygen has been added to what? To it. Okay, so the last question. So basically in this case here, which substance is oxidized? Aluminium is what? Aluminium is oxidized. Aluminium is oxidized. So the answer to that is A. Question 4 here, which changes is oxidation taking place? So just look for the one in which you have oxygen, increase in what? In oxygen, and that's basically what D. You have here oxygen 3 and here is 5, so you have an increase in oxygen here. Okay, so now we'll look at energy changes accompanying chemical reaction. So the basic idea here is that during chemical reaction there is always energy changes. So it's either there is an increase in energy or a decrease in energy. And of course, energy can neither be created nor destroyed. So if, for example, this is a substance A, okay, and substance A is changed to substance B. So in chemistry, we're saying that sometimes when this change takes place, A might require that before the reaction takes place, it takes in energy, okay, absorbs in energy, and this energy is usually in form of heat energy. So when A absorbs heat energy, it uses that heat energy to carry out chemical reaction, and so it's converted to B. So in this kind of reaction, we can see that it has to do with absorption of what? Energy, taking in of energy. It's also possible that a reaction can take place in which substance A can convert into substance B, but in doing so, heat energy is released when that conversion takes place. You can see it's opposite. Okay, here in one, A takes in heat energy and is converted to B, but in reaction 2, the change from A to B, it's almost automatic, and so when that change takes place, heat energy is released. So here we have two kinds of chemical reaction, one in which heat energy is absorbed, and that is called endothermic, and we have the other reaction in which each energy is released, and that is called exothermic reaction. Okay, so here certain example of exothermic reaction. So exothermic reaction gives out energy. Exothermic reaction gives out what? Energy. But endothermic reaction absorbs energy. So for exothermic reaction, there is a temperature rise. So because if this gives out energy and you dip your thermometer, if a reaction is taking place in sieve, for example, okay, so for an exothermic reaction, there are key things that you need to know. You need to know how to draw the energy level diagram. Okay, this is what is called the energy level diagram. So for exothermic reaction, the reactant has a higher energy. You can see here, for example, if we're starting with 10 joule of energy and we ended with say 8 joule of energy, there is a shortage of 2 joules of energy, and that 2 joules of energy is the energy lost as what? Heat energy, which your thermometer picks up and recognizes as temperature rise. So exothermic reaction is accompanied by increase in temperature. This is because the reactant is converted to product with the release of energy. So if you have reactant, okay, forming products plus energy. So if I start with 10 joule and product is 8 joule, that means 2 joules of heat energy has been what? Lost to the surrounding. And so how do we show that? We show that by using a negative sign, minus 2 joule of energy. So when you have this energy change called enthalpy, okay, and you have minus with a certain value, and of course the unit, this negative indicates exothermic. That means heat energy is released. So the minus sign shows that energy is what is given out. So you can look at examples of exothermic reaction. Okay, so for endothermic reaction, let me just focus on this you're familiar with. Sometimes you put glucose in your mouth or citric acid and you notice a kind of cooling effect. The reason is because for the glucose to dissolve, it absorbs energy, heat energy in this case, from your mouth or from your tongue, and the energy is being used to dissolve the glucose. So because heat energy is being taken out of your tongue, it is expected that the temperature of your tongue goes down, and that's the cooling effect that you have. Okay, for another example of endothermic reaction, decomposition of calcium carbonate. Calcium carbonate is CaCO3. When it decomposes, it breaks down into calcium oxide plus carbon dioxide. Now this decomposition requires heat energy. That means heat energy has to be given to it. And if you look at this diagram, you can see that heat energy is being given to the container, and you have your calcium carbonate decomposing on the inside. So because heat energy is being absorbed, you would expect that the chemical energy, okay, of the product will be more than that of what? That of the reactant. So in this case now, if I'm to rewrite this, it will be calcium carbonate plus energy, okay, to now give calcium oxide plus what? Carbon dioxide. We have said earlier that the total energy of the reactants will be equal to the total energy of the product. So if I have 8 joule of energy in my calcium carbonate plus 2 joule of energy, okay, added to it, then I would expect to have altogether here 10 joule of what? Of energy. So basically, for an endothermic reaction, the energy profile is represented like this. You started with a certain example, 8 joule, you ended with 10 joule of what? Of energy. So it simply means that 2 joule of energy has been what? Added to the reactant to now form 10 joule of what? 10 joule of product. Okay, so for an endothermic reaction, energy is absorbed, energy is taken in. So the plus sign indicates that what? Energy is what? Is taken in. Okay, so now in looking at the concept, it may sound confusing sometimes, but it's something you will need to understand. Okay, if this is a reaction vessel, okay, this is a reaction vessel, and so I decide to put my thermometer inside. The thermometer does not measure chemical energy, the thermometer measures heat energy. So if this is an endothermic reaction, you would expect that the reactant will absorb energy from the surrounding into the chemical. So because the energy is taken away from the surrounding, the thermometer picks or recognizes this as a decrease in what? In temperature. Okay, so you are measuring the temperature of the surrounding. It's the surrounding that lost energy to the chemical. So the thermometer measures the heat energy of the surrounding and it recognizes that as a decrease in temperature. Now on the other hands, if there is another reaction taking place such that heat energy is lost to the surrounding, so if it's the other way around, that heat energy is lost to the surrounding, okay, the other way around, the thermometer picks up the heat energy that has been thrown into the surrounding, and that will be seen as an increase in what? In temperature. So basically, exothermic reaction can be seen as what? As an increase in temperature, while endothermic reaction can be seen as what? A decrease in temperature. So your class work, you are just going to draw the enthalpy diagram for exothermic reaction and enthalpy diagram for endothermic reaction. Okay, your second class work, you're going to solve this this problem, okay, in your notes. And the third and fourth question is this. Okay, so I just want to give you hints on this. Just focus on this when you ask questions like this. The energy change for this reaction is this. What can you conclude about this reaction? So you are focusing on the sign. If the sign was plus 822.4 kilojoule, what would you say? Would the reaction be exo, or would the reaction be what? Endo? Just go through your textbook and go through the video again. You will be able to solve this problem. I will see you in lesson 2 of this course.